This presentation looks at how humans remember, how algorithms learn, and why data science still matters in the age of artificial intelligence. Using number sequences as an entry point, it examines how pattern recognition drives machine learning, where current AI systems still struggle, especially with novelty and nuance, and why understanding algorithms' bias and limitations remain valuable. Beyond using AI tools, the real opportunity lies in improving them. Which is easier to remember? Is it set A? Now try set B. The second one is longer but easier to remember. Why? Because there is a pattern. The numbers decrease by 2. The human mind and machine learning both depend heavily on patterns. Now consider set C. At first, this set looks chaotic, but is it really so? But look closer. 8, 12, 16, 20. This increase by 4, and between them the numbers multiply by 3. Suddenly, what seemed difficult becomes memorable, because once again there is structure, there is hidden order, and there is algorithm. How far can such patterns go? Mathematics contains patterns so powerful that they generate numbers beyond imagination. Graham's number, a number so large that its full decimal representation could never be written in the observable universe. Its last 16 million digits have been published, with the last 1000 digits being shown. The ability to calculate even the last 16 million digits of Graham's number demonstrates the ingenuity of human mind and the power of mathematical algorithms. Patterns and algorithms make even the seemingly impossible partly understandable. This simple idea reveals something important about both human intelligence and artificial intelligence. That is, recognizing patterns is powerful. Machine learning, the foundation of modern artificial intelligence, is built on this principle. Machines built on these concepts do not think the way humans do. They learn from data by identifying patterns, using probabilities, and finding relationships. But if recognizing patterns is all that machine learning does, an important question arises. Does recognizing patterns equal intelligence? Not necessarily. Highly advanced systems that recognize thousands or millions of images may still lack true general purpose intelligence. Pattern recognition alone is not the same as human understanding, adaptability, or reasoning. Yet these systems are already capable of generating text, images, and code that often appear remarkably intelligent. If AI can already generate text, images and code, the question arises whether learning data science is still worthwhile. One way to see why data science still matters is to look at systems used every day by millions of people. Consider, for example, the recommendation algorithms used by YouTube. Many creators of YouTube videos notice something frustrating. When content is slightly unusual, tailored to a slightly different audience, or slightly outside established categories or niches, the algorithm often struggles to reach the right audience. Why is this? Because recommendation systems still depend heavily on learned patterns from prior behavior. If the content does not fit known structures well enough, the algorithm may not know where to place it because the system has seen fewer similar examples before. Image analysis have advanced since AlexNet in 2012, but there are still many areas where there could still be improvements. The image analysis algorithms that differentiate pictures of wolves and dogs, which were shown earlier, might learn to recognize the wild and less wild background of the pictures and not the features differentiating the dogs and wolves. AI systems trained on initial images may sometimes struggle when familiar objects appear in unusual contexts. For example, dog with clothes, which are a trend nowadays. This means that even some of the world's most widely used AI systems still face limitations in understanding novelty, nuance, and emerging complexity. However, every limitation is an opportunity for better models, better feature engineering, better recommendation systems, and better human AI collaboration. This is why data science remains valuable. Learning data science is not just about using the existing tools, it is about understanding how patterns are detected, how data is represented, how bias enters models, why algorithms fail, and how systems can be improved. The future may not belong only to those who use AI, but to those who understand its weaknesses. AI is powerful. Machine learning is transforming the world, but there is still enormous room for improvement. Just as set B and set C became easier to remember once patterns were understood, the future belongs to those willing to see beyond the surface, to question the algorithm, to improve the model, and to build better systems. This is why learning data science and machine learning is still worthwhile. I believe very much that the next breakthrough will come from someone curious enough to keep learning. The roadmap shown is taken from a very good book. When most people talk of machine learning, they are more concerned with machine learning algorithms that are involved in the task of classification, regression, and clustering. However, it is important to realize that raw data collection and pre-processing of data are among the most crucial steps. This is the book that I mentioned earlier. and I have it in the digital version. I hope you will join me in future explorations where these topics are discussed in greater detail. Books that have been particularly helpful, along with practical lessons learned along the way, will also be shared. The journey into data science began more than 20 years ago, yet the learning continues. There is still much to discover, and there are still many ways in which data science can contribute, particularly in the field of health sciences. Thank you for your time, and I hope to see you again in future videos.